When it comes to cost optimization, most of the people focus on either EC2, EBS snapshots, EBS volumes, or RDS, and serverless application seems to be an afterthought. And I'm talking about AWS. And then AWS, the premier and leading serverless technology is AWS Lambda, which is a managed serverless function service. In this video, I'm going to explain how Lambda costing works, what it involves, and how you can save cost in Lambda. And there are ways, if you use them properly, you can save a lot of money in AWS when it comes to Lambda. So let's first try to understand how Lambda costing works. Lambda uses a pay-per-use cost model that is driven by three metrics. First one is all about memory. In AWS, when you create a Lambda, you can assign memory from 128 MB to 10 to 40 MB. And remember that as you increase the memory, its CPU increases and vice versa. Then we have function duration, which is the limit at which a function can run, and it is measured in milliseconds. Then we have number of invocations, which is the number of times your function runs. Over provisioning memory is one of the primary drivers of increased Lambda costs. This is particularly acute among builders new to Lambda who are used to provisioning hosts running multiple processes. Lambda scales such that each execution environment of a function handles only one request at a one time. So each execution environment has access to fixed resources, which is memory, CPU, and storage, to complete work on the request. By right-sizing the memory configuration, the function has the resources to complete its work and you're paying for only the needed resource. So it means that if you are setting the memory, then make sure that you're setting it properly. Don't overset it and don't underset it. Because if you overset it, you are just wasting your money. And if you are underset it, the function is working hard and maybe costing you more money in terms of CPU, and your work is getting delayed, and you might think that okay, I need to increase the function duration. Now the question is how you can make sure that you have assigned the optimal memory. In order to do that, there are two tools which you can use. One is called as AWS Lambda Power Tuning, and the other one is AWS Cost Optimization. AWS Lambda Power Tuning is an open source tool that can be used to empirically find the optimal memory configuration for your function by trading off cost against execution time. The tool runs multiple concurrent versions of your function against mock input data at different memory allocations. The result is a chart that can help you find the sweet spot between cost and duration. Depending on the workload, you may prioritize one over the another. AWS Lambda Power Tuning is a good choice for new functions and can also help select between the two instruction sets architectures offered by Lambda, which I'll mention shortly. The other tool is AWS Compute Optimizer, which uses machine learning to recommend an optimal memory configuration based on historical data. Compute Optimizer requires that your function to be invoked at least 50 times over the trailing 14 days to provide a recommendation based on past utilization. So it's most effective once your function is in production. So if you're deploying a new function and you want to set the optimal memory value from the start, use Lambda Power Tuning. But if your function is already running in production and you want to review the memory allocation, then use AWS Cost Optimizer. Okay, and I will put the link to this Lambda Power Tuning in my video's description. Now let's look at some of the ways you can save cost. First and foremost, after checking the memory and setting the memory, second thing is that set the realistic function timeout. What it means is that Lambda functions are configured with a maximum time that each invocation can run, which is up to 15 minutes. Setting an appropriate timeout can be beneficial in containing cost of your Lambda based applications. Moreover, unhandled exceptions, blocking actions, and can also just prolong your function runtime. Proper timeouts are the best protection against both slow and erroneous code. At some point, the work the function is performing and the per millisecond cost of that work is wasted. So I would highly recommend is to set a timeout of less than 29 seconds for all synchronous invocations or those in which the caller is waiting for a response. Longer timeouts are appropriate for asynchronous invocations, but consider timeouts longer than 1 minute to be an exception that requires review and testing. Okay. Second recommendation is to consider using Graviton. So Lambda offers two instruction set architectures. One is x86 and the second one is ARM64. Choosing Graviton can save money in two ways. First, your functions may run more efficiently due to the Graviton 2 architecture. Secondly, you may pay less for the time they run. Lambda functions powered by Graviton are designed to deliver up to 19% better performance at 20% lower cost. So consider starting with Graviton when developing new Lambda functions. But beware that if your function relies on native compiled binaries or is packaged as a container image, you must rebuild to move between ARM64 and x86. Lambda layers may include dependencies targeted for one architecture or another. So make sure you are aware of it. Lambda is integrated with over 200 event sources, including SQS, Kinesis, DynamoDB, Kafka, MQ, and lot of others. The Lambda service integrates with these event sources to retrieve messages and invoke your functions as needed. When working one of these event sources, you can configure filters to limit the events sent to your function. This technique can greatly reduce the number of times your function is invoked depending on the number of events and specificity of your filter. So you don't invoke your function for needless triggers. Recursion is a nemesis for all the programs. In programming concept, recursive function, means that a function which calls itself. This can happen in Lambda too. For example, one of the common recursive pattern which I have seen is that um, when people are using Lambda with S3, actions in an S3 bucket can trigger a Lambda, and then a recursion can occur when that Lambda function write back to the same bucket. So be aware of that and make sure you're not using the pattern like that. Lambda offers a number of techniques which we have just discussed to minimize infrastructure cost when you are just getting started or have numerous functions which are already deployed in production. When combined with the lower cost of initial development and ongoing maintenance, serverless like Lambda can offer a total cost of ownership in very low figures. So I hope this was useful if you're using Lambdas and looking to save some cost. If you have any feedback, please put them in the comments. Thank you.